Watch this video in Lesson Reach. Pause and ask questions, take a quiz, or get help with assignments. Link below.
Welcome, to today's deep dive. Imagine like a massive rectangle that holds every single piece of data in the known universe. Now, how do you actually find the one thing you care about without completely losing your mind? Today, we are unlocking a visual shortcut for organizing complex information, and we're using section 1.3 of chapter 1 from Contemporary Mathematics to do it.
Yeah, and since we are diving into some foundational set theory today, we're actually trying out a fun little dynamic. I'll be stepping into the lecturer role, mapping out the structural logic behind these ideas.
Which means I am officially putting on my student hat. But, consider me a highly skeptical student who wants to know how this actually applies to real life. Okay, let's unpack this.
Sounds good. Let's start with the big picture. When dealing with abstract logic or massive data sets, our brains physically struggle to process raw information.
Oh, for sure.
Right. So section 1.3 argues that we need a cognitive boundary to make sense of it all. Enter the Venn diagram. Just like assembling furniture is way easier with pictures, abstract logic is easier with diagrams.
That is a very fair point.
We start by drawing that large rectangle you mentioned earlier, which represents our entire data set, the universal set, or U.
Okay, I get that the rectangle is our whole universe. But if the rectangle is everything, how do we represent the specific things inside it?
Well, you use subsets, so basically you draw circles completely inside that rectangle.
Grouping things together.
Exactly. The textbook uses this great example. If your universal set, the whole rectangle, is plants, then the subset circle inside it could be trees.
Ah, okay. Because all trees are plants.
Right. You're visually declaring a structural law. Every single item in that circle shares a defining characteristic.
Now that we know how to place a group inside a universe, what happens when we have multiple groups that have absolutely nothing to do with each other?
Well, then we were talking about disjoint sets.
Disjoint sets. Okay.
Yeah, they're non-overlapping. Circles within our universe that just never touch.
Let me step in and test my student understanding here with another textbook analogy.
Go for it.
So if our universal set is cats.
Okay, keeping it feline.
Right. Then lions and tigers are two separate circles inside the rectangle that never touch. Totally separate.
You got it. What's fascinating here is how these simple visuals instantly clarify non-overlapping data. You just know those boundaries never intersect.
We've mapped out what is inside the circles, but I want to talk about the empty space floating around them, like the data that isn't safely trapped inside a circle.
That negative space is mathematically crucial. It's called the complement of a set.
The complement.
Yeah, we write it as A prime. It represents all the elements in the universal set that are not in your subset.
Wait, let me solidify this for you listening right now. If our universal set is single digits, 0 through 9.
Sure.
And subset A is prime numbers. So, 2, 3, 5, 7.
Right.
The complement, A prime, is everything left over in the rectangle. 0, 1, 4, 6, 8, 9.
Exactly. Sometimes the easiest way to find something is by defining exactly what it isn't.
So what does this all mean? Why should you care about empty space in a mathematical rectangle?
Because the tools from section 1.3 aren't just for math class.
No, they are really practical frameworks to quickly visualize relationships and avoid information overload in your daily life.
Definitely. If we connect this to the bigger picture, whenever you are overwhelmed, mentally drawing a Venn diagram forces you to see what truly overlaps and what is totally disjoint.
It fundamentally changes how you process the world around you,
Yeah.
which honestly leaves us with one final thought to ponder.
Oh, I like where this is going.
If a Venn diagram can map out everything we know, what does the complement of your own life's knowledge actually look like? What completely untapped ideas are just hiding out there in the negative space